Am I going? Yep, I'm gone. All right, so I'm going to use red for the hydrogens. So I'm just going to kind of mark the hydrogens so I can clearly see what they are. And I'm going to use blue for the nitrogen. Again, just so I can clearly see. This one's easy, right? There's some of the hydrogens are little and the nitrogens are big. But look down the page there. Can you see how it gets a little bit more confusing as to what these things are? You can still tell, but I think adding color to these really does help. So we're going to be building what kind of molecule? NH3, that's my product, right? I'm starting with hydrogen and nitrogen mixed together, and I'm going to build some NH3. So I'm going to just start building molecules. So here's one. There's my nitrogen. How many hydrogen am I going to need to put on this? 3, because it's NH3. Now I'm going to take my pen, I'm going to come over here, I'm going to cross off, I've used up one of the nitrogen, and I'm going to cross off 3 of the hydrogen. Can I build some more? Yeah, I'm going to go ahead and build another one. I've got 1 nitrogen, 3 hydrogen. Now I'm going to cross off the ones I've used. 1. There I go. Can I build more? This is just like building the bicycles, right? I still got parts. And another one. 1, 2, 3. Cross off the ones I've got. Let's say I just used nitrogen and 1, 2, 3 of the hydrogen. Can I build more? I can build more, so I'm going to do another one. Cross off this. Can I build more? No, I can't. Now, what do I have left over? 4 individual hydrogen atoms, but how many molecules do I have? 2 molecules of hydrogen. So I'm going to just, whoops, let me draw them in red. I'm just going to draw them here, and I'm done. How many excess molecules of hydrogen did I end up with? 2, H2. Do you see how I didn't have to do any math there? I literally was just building molecules. What did I have left over? Drew it in the box and wrote that down. Okay? That is a legit way to do this, but it takes a lot of drawing and it takes a little bit of time. The next thing I'm going to show you is how to do it mathematically, but this does require you to balance reactions because we're going to be using those coefficients. Now I'm going to do 2 or these, maybe 3 of them, all right? So hopefully by the time I'm done, you'll be like, I can do the math way, no problem. And that's what I'm going to do. Because I really do think the math way is faster, less chance of I've seen lots of people make mistakes because it's hard to keep track of all these circles. And so it'll save you some mistakes. So the first thing I'm going to do is I'm going to balance this reaction. And I'm going to zoom in and kind of balance it right here. So I've got nice reaction here. Only 2 elements. That's kind of nice. I'm going to go ahead and I'm going to do my reactant side. How many nitrogen? How many oxygen? On the product side, how many nitrogen? How many oxygen? Bum, bum, bum. I'm already balanced just the way it is. I don't need to put any coefficients there. They're all 1s, right? So now, this is just like your stoichiometry problems. I need to say, what do I know? So how many of the NO molecules do I have? Okay, so again, I'm going to do this. The greens are going to be my nitrogen. The blacks are the oxygen. All right. So how many NO molecules do I have? I've got 5, right? So I'm going to, just like I did for my other problems, I'm going to put my known under what it is. How many of the oxygen molecules do I have? I've got 3. Everybody with me here? I've got 1, 2, 3 of the oxygen molecules. Okay? Now I've got my 2 knowns, just like I do in the stoichiometry one. And the ones we did yesterday, you'd be putting grams, the grams of each one that you had. Remember that? Okay? So now I'm ready to do the stoichiometry part of it, or to do this, not the math way to do this. I'm going to take NO first. How many did I have? How many do I have for nitrogen? I've got 5. So 5NO. If I have NO on the top, I need, this is my bridge. So what number is going to go with the NO? This is the bridge. It's 1 because there's my coefficient. So I'm going to say 1 NO. So what's the ratio between the NO and NO3? Because that's what I'm going to end with. Right, there's the coefficient for NO3. So how many do I get? How many do I end up with? 5 times 1 divided by 1 is going to be 5. So I'm going to end up with 5 NO3 using the amount of nitrogen, the NO I started with, right? Everybody see where these numbers are coming from? Now the second part's easy. Again, what was my known? My known is, what? Yeah, I'm doing it's 3 oxygen molecules. I should have said what was the other known. If I have oxygen on the top, yep. What coefficient am I going to need for oxygen? 1, O2. What coefficient? This is my bridge. What is the coefficient for NO3? It's the same the whole way through, right? So now, how many am I going to get with using oxygen? I'm going to get 3 NO3. Which one was limiting? The oxygen. I ran out first. All you have to do is circle it. You don't have to do the excess reactant. Right? So let me do another one so you can watch it again. And then I'll turn you guys loose and see, I'm going to do the mathematical one because I really feel like that's the better way to go. But I want to make sure you guys feel comfortable with it. So what's the first step here? I have to balance my reaction. So if I zoom in with this, I should be able to write small enough so I can balance that. So I've got oxygen, fluorine, and hydrogen, right? So how many oxygen am I starting with on the reactant side? How many fluorine? How many hydrogen? Now I'm going to go to the product side. How many oxygen? How many fluorine? How many hydrogen? What am I going to do to fix the other side, the product side? Put a 2 here, update my totals, and I'm balanced. So these coefficients are going to be 1, 1, and 1, okay, and the 2. Everybody good with that? Just a little balancing. If you want use a piece of scratch paper to balance your reactions, feel free to do that. Yeah, you don't need to show me your work for balancing the reactions. So if you want just a plain piece of scratch paper just to balance those, then that'll be fine. So now what I'm going to do is, see, and this is the one that I feel like, ooh, coloring these in is good. So I'm going to color in my hydrogen red. I'm going to leave my oxygen black, and I'm going to do my fluorine green, just so I can really see the difference between those two, because I think because they look the same, they're just different sizes, it's kind of hard to see. So what am I going to start with for OF2? I've got how many of them? 2. So I'm going to write that down. How many of the water do I have? 5. Now I'm ready to do my calculation. So I'm going to go, so how many what's my known? 2 OF. If I have OF on the top, I need, so I'm going to get my coefficient, because this is my bridge to go from my known to my unknown. So OF2. What's going to be on the top? Yep, I'm going to choose to do 2HF. You can choose to do either product you want to. I'll be able to see which one you chose by looking at your work. Okay? I'm going to choose to do HF, so it's going to be 2HF. So what does that end up being? 4. So this is going to produce 4 of the hydrogen fluoride. Now what's my next step? Do the other known. Yeah. And how many did I have? What's going to go on the bottom? What's going to go on the bottom? Yep. 1 H2O. What's going to go on the top? What is it? What's going to 2HF. Now how many do I get? What was my limiting factor? Which one? The OF. Just circle it, and that's all you have to do. Do you guys want to see me do this last one here, and then you'll do the back side? Okay. So what's the first step? Got to balance it. So I'm going to zoom in here, and I'm going to balance it. So I've got sulfur, oxygen, hydrogen. I've got 1, 2, and 2. Over on this side, I've got 1, 1, and 2. So I got to go for the oxygen. How am I going to make 2 oxygen on this side, the product side? Put a 2 here. Update my totals. 2, 4. Whoops, not balanced now. How am I going to fix that one? Yep, 2 over here. Now I've got 4. And the rest of the coefficients will be 1s. This one's not too bad. I mean, like I said, you don't have to use different colors to do this. You can kind of see the difference here pretty easily. Sulfur, I'm just going to do as green. All right, so let's do, what is my total for the SO2? I've got 3 of them. How many molecules of H2 do I have? Okay, now I'm ready to do my problem. What's my known? 3 SO2. What product do you guys want to do? You want to do the H2O or the S? Which one? H2O? That's the first one I'm hearing. So if I've got 3 SO2 on the top, I need this coefficient, 1 SO2 on the bottom. And what's going to go on the top? 2H2O. Now let's say for a second that you decide you want to do the sulfur. You could do that. You're still going to find out that one thing runs out. So you're still going to be able to pick your limiting factor. Okay? And I'll know which one you pick just by looking at your problem. So how many do I get here? I get 6 H2O. So now, what's next? Yep, 4H2. H2 on the top, I need, what number is going to go with the H2? Yep. And now the same thing goes on the top, H2O. How many do I get? 4 times 2 is 8, divided by 2, I get 4. Oh, this was funny. It's somebody sitting right here. They're doing one of the problems, and I'm looking at their setup, and I'm like, yes, that's right, that's right, that's right, and their answer's wrong, and I know the answer's wrong. It was because they'd forgotten to divide by 2, and I'm sitting there looking at the same problem, and I can't figure out. It was the same thing, and you got to divide by the number in the bottom, and I'm looking at it, I can't figure it out, and then all of a sudden it dawned on me, oh, wait a minute, you didn't divide by 2, and then you had the right answer. So what is the limiting thing for this one? Yeah, there you go. That's it. All right, so you're going to flip this over. You're going to do the 4 on the back. Again, if you feel like you want to draw them, you can, but this is much shorter and quicker to do. I am still going to be able to come around and help you out, but this requires balancing them. If you can't balance the reaction, then you can't use those coefficients to convert from one thing to another.